Today we will be seeing if the solutions that are given are actual solutions. And so what we'll be using is substitution to determine whether the values that the variables say they are actually those values. So let's look at our first problem here. It says, again, the directions say for each equation, determine whether the given value of the variable is a solution. A solution means that when we substitute this 8 in for this d, because that's what it says 8 equals, it should equal 24. So let's see if that works. So the 2 right next to the d means that we're going to multiply. Well, when I multiply those two numbers, 2 times 8, I get 16. And that does not equal 24. So that would be no. That is not the solution. So that's what we're doing on these three problems. We're just substituting the numbers into the variable and seeing if it actually is the solution or not. So the reason why we do this is because this is how we're going to determine whether we have the right answer. Is that if we get our answer and we take it and put it back into the original equation, it should equal the number it initially was. So if we got 15 for our answer, we'll put 15 in for x. We'll do the division, and here, when we do that division, we do get 9. And that equals 9. And so when the two numbers equal, then, yes, that is the solution. Taking a look at our last type of this regular problem, we're going to just take that 20 and put it in for this t right here. So now we've got 7 plus 20 minus 4. So when we see if do that order of operations, see if it equals 22 or not. Well, when we add these two numbers together, we get 27. 27 minus 4, is that 22? Not quite, it's 23. And so no, that is not the solution. T does not equal 20. Well, we have some word problems. And so what we're going to end up having to do on these problems is see if we can write an equation, and that's what we're going to be looking at. And this is an important concept because in a lot of life's problems that involve math, we want to write an equation to match a situation. And then from there, we want to be able to define the variables, and that's what we're going to be asked to do here. So it says Mr. Yakimas teaches 4 science classes with the same number of students. So let's underline the important information. 4 science classes. It doesn't matter whether it's a science class or not. So I'll just say 4 classes with the same number of students. That's important. Same number of students in each class. Of those students, 80 are 6th graders. That might be important later on. We'll see. 40 are 5th graders. And then it says to write an equation to model the situation using the variable n. What does the variable represent? Well, what don't we know? We know there are 80 5th graders, or 80 6th graders, 40 5th graders. What we can do, though, with that number is we can take that 80 and that 40 and we can add it together. Well, what's that going to give us? That's going to give us the total number of students. So this equals the total number of students. So that's what that represents when we add those two numbers together. Well, this part also gives us something about the total number of students. 4 science classes with the same number of students. That's what he teaches. So he teaches these 120 kids here. So if I was to add that together, that's what that makes, 120. But there's another way to come up with that. If I knew the number of students, the total number of students in each class, I could multiply it by the number of classes that he teaches. So he teaches 4 classes times the total number of students would equal this equation here. And so that's the equation that they're looking for, is right here. 4n equals 80 plus 40. They're not asking us to solve here. They just wanted us to write an equation. And then they also want us to define the variable. N equals the number of students in each class, because he has the same number in each class. Let's take a look at our next one here. Mary put new tiles on her kitchen floor. The floor measures 6 feet long by 5 feet wide. That's important. That gives us the total area that she ended up putting the tiles on. She used 10 tiles, that's important, to cover the entire floor. Okay, so 10 tiles covered the floor. Each tile was 3 feet long. Well, they don't give us how wide the tiles were. We know the tiles, if this is a tile, we know that one dimension is 3 feet. We just don't know what this other dimension is right here. And that's what they're asking for here. Write an equation using the variable x to model the situation. So let's see what we know. We know the floor is 5 by 6. So 5 feet times 6 feet. This is the area of floor. And so what we're going to set that equal to is another representation of that area. So the area of the floor could also be measured using the tile. So we know there are 10 tiles. We just need to know what the area of one of those tiles is. Well, we know one dimension's 3. We just don't know that other dimension. So that's why we're using x for that other dimension. So 3 times x. And then we've got our equation. So we can go ahead and solve for x if we wanted to, but for right now, that's all we had to do is just write the equation. So the area of the floor found 2 different ways. And from there, x is the width of the tile. Well, looking at our next one, Emmanuel put 12 marbles on a scale. Okay, so 12 marbles on one side, and on the other side he put 4 marbles. So 4 marbles on the other side. Then he added 8 marbles to that side. So he added 8 to this side. And each marble weighs the same amount. Each marble weighs 1 ounce. Is the scale balanced? Well, the scale being balanced means that these two numbers are going to equal each other. And this side's 12. 4 plus 8 is also 12. So yes, it is in balance. And we could say that both sides weigh 12 ounces. Our next problem here deals with Bill and Rhonda have the same amount of money, so that's an important part. So we have Bill here, we have Rhonda over here, and they both have the same amount of money, so we'll say they equal each other. Bill has $13, so let's put 13 in place of Bill. We know that Rhonda also has $13, but let's see what they say. Rhonda has one $5 bill, so 1 times by a $5 bill. 3 $1 bills, so 3 times the $1 bill. And one other bill. We just don't know what type it is. And is it a 1 or a 5, they say? Well, let's put an X. X represents the other bill. So this is the other bill. We just don't know what size it is. Is it a 5 or is it a 1? So let's go ahead and do some work. We know it needs to equal 13, so this is 5. This is 3 plus X. Well, these two add to make 8. So what plus X equals 13? Well, if I subtracted the 8 from both sides, that would give me the amount. And X would end up equaling 5. So it would be a $5 bill that Rhonda had extra. Well, here it says Carla had $15. After she bought lunch, she had only $8 left. So she had 15, but now she only has 8. Well, we need to use a variable to write an equation. So we don't know the cost of the lunch, and that's what the X represents. So X equals the cost of lunch. We don't know what that is, but if we take that away from $15 that she initially had, she only has $8 left over. 72 people signed up for a soccer league after players were evenly divided. So 72 players signed up. Players are evenly divided into teams. There are 6 teams. So we're supposed to write an equation and model this. We're supposed to use the variable x. Well, x is going to equal the number of people on one team. So number of people on one team. So we have 72 divided by the number of people on one team, which is X. We don't know that number. And then that equals 6. And that is our equation to match. Well, those are the types of problems that you're going to see on tonight's homework. Good luck.